Yes, today we are starting with chapter 14, structures. Let us explore this chapter. So here, structure is a collection of simple variables. The variable in a structure can be of same or different data type. Some can be int, some can be float, and so on. The data items in a structure are called members of the structure. See, structures are basically required to define user-defined data types. Right, user-defined data types. Like, arrays, it's a feature which will help you to store a group of values of similar data type. Whereas in structure, it is not like that. It's a collection of simple variables. It's a collection of variables of different data type. Right. Variables can be of same type or they may be of even different data type. So to learn the concept of object-oriented programming, which is an advanced improvement of the structure itself, that is why they are introducing structures here so that you can understand object-oriented programming concepts, especially classes programs, you can handle it properly. So to understand, to write programs related to the classes, understanding this chapter is very important. So here, if you want to define the structure or declare the structure, what do you have to do? You should write a keyword struct and the structure name. And you can opening brace is there. And members have to be declared. So the syntax for declaring member is what? Data type and the member names. So like that, any number of members can be declared. Here, the structure name is also called as a structure tag, right? It is also called as structure tag, and struct is a keyword to declare the structure. Opening brace is there, and even at the end, closing brace with semicolon is that. That is very important. So the list of all structure members can be called as what? Template. We call it as a template. So here the structure definition serves only as a blueprint of the creation of variables. It does not itself create any structure variable. That is, it does not set aside any space in the memory or even name any variable. Right. This is simply what it's a blueprint. See one example for employee. Struct is a keyword. Employee is the name of the structure. Then here inside the structure, you see they have declared 4 members. One is ID number of type int, name of type string, designation of type string, salary is of type float. Right. Here you see, even though character is there, I pronounced it as string because they have used square brackets. That square bracket says that it's a character array. Character array is nothing but strings. So once when this structure is declared, so here you see int will take 2 bytes of memory, name will take 15 bytes because 1 character means 1 byte, 15 character means 15 byte. Similarly, 10 bytes for this designation, 4 bytes for salary. So the total amount of memory required for storing one structure variable detail is 31 bytes. This is the memory allocation for a structure. Now here, once after declaring the structure like this, how struct employee is done, if you want to take advantage of this or if you want to make use of this, what do you have to do? You have to write structure name variable. Student, old student, new student, right? Like employee, EMP1, EMP2. So EMP1 and EMP2 are structure variables of structure employee. So with the help of these variables, you will be able to access the structure members. Until and unless the structure variable is declared, so the structure members are of no use. Now you see the one more way of declaring the structure variable. Here first we declared the structure and then structure variables are declared, right? But here at the time of declaring structure itself, you can declare the variable. See, this is the structure declaration up to this. Just beside this closing brace itself, structure variable name separated with comma with semicolon is written. So they are nothing but structure variables. Two structure variables are declared. So the memory for two structure variable will be allocated separately. That is what EMP1. EMP1's ID number, name, designation, salary to store all these details. One separate set of memory. For storing the details of EMP2 structure variable, one more set of memory will be there, right? So once after declaring the structure variable, either by using this method or by using this method, how to access these members into the program. So if you want to access those members of a structure, then what you have to do, you have to take a support of a dot operator. So the syntax for this is structure variable name dot member name, right? So for example, here you see EMP1 dot name, EMP2 dot salary. So one complete program on it. See, first required header files are included and void main structure student. See, inside the main only they are declaring the structure. After declaring the structure, ST structure variable is declared here only. ST is a structure variable, right? And then they are asking the values. Enter the name of the student, then enter the combination, registration number, percentage, and they are printing all the details at the end. So we are feeding all this, and at last your result will be printed. So here these all values are displayed. Initializing means at the time of declaration of variable or the structure, you can provide some meaningful values to the structure members. For that, you see here, while declaring structure variable, they have provided the initialization. It is employee EMP1 equal to, as per the sequence of like members, how in what sequence you are written. In the same sequence, you write the values. Based on that, values will be assigned to the corresponding members belongs to the EMP1 structure variable. That is EMP1.id will become 1, 2, 3, 4. EMP1.name will become Lakshmi. EMP1.job or designation equal to this. Like this, it continues. Right. As per the required data type, the initial values formats third place. And after that, see, STD1 is assigned to STD2. So now what happens here? STD1 and STD2 are the structure variables of the structure STD. There is one more problem. To find sum of two distances, where a distance structure is made up of two variables, feet and inches. Right. After that, inside the main, they are initializing the structure variable D1 with three values. with two values. 5 is a feet, 6.75 is a inches. Now distance D2 and D3. D2, they are taking input from the keyboard. And then D3 in the sense, D2, D3. Enter the second distance in feet and inches. So feet and inches. See, they have written D2 dot feet, D2 dot inches because here they are the variables of the structure distance. So they are having permission to access like this. Now here the inches is calculated. D3 dot inches equal to D1 dot inches plus D2 dot inches. Feet is initialized to 0.0. Now here, whatever the inches are there in the D1 and D2, then it will be stored into the inches. And if D3 dot inches is more than 12, then what happens? D3 dot inches is equal to minus 12.0. D3 dot inches equal to D3 dot inches minus 12.0, and feet will be increased by 1. Right. And here both feet are added. And then here 4 values are printed. Now, along with that, see, feet and inches of all D1, D2, D3 are printed. Nested structure. A structure within another structure is called as what? Nested structure. See, struct distance, struct room is there. Inside the struct room, they are declaring two members. Distance length, distance breadth. Two objects of type distance class is being created inside another structure called as what? Room. This is called as nested structure. So here there is a struct date. And then these are the members of structure student. And then one more, here date structure is declared. Struct student, int registration number, character, name, then date, DOA. And now here they are taking input values for name, day number, and all the details are being printed here. Here input is taken and output. Now here, in this one, how to access them? See, dining dot length dot feet equal to 15. So like this, you can access it from the nested structure variable possible. Width and height. And then calculation is done and result is printed. Now, arrays of structure. Arrays feature can also be applied for structure so that more than one array variable situations or requirement can be completed very easily. How to declare first? A of 100. See, S of 100. That means struct student. S is the array of structure student which contains all these values, all these members. Suppose if there is a S of 0, S of 1, S of 99, up to that, right? These are all what? Members. Right. So now, one more program. Struct info. 3 members are declared. Main. Info. S of 50. And then int in, comma, L. So now enter the number of students, as there is an array, group of values will be there. So then enter the registration number, percentage, name of student. So all those inputs we are taking. And now what happens is at last all those details will be printed. This is all about structures.